Today we're going to look at parallel and perpendicular equations. Parallel equations are equations with the same slope. So anytime I want parallel lines, I'm going to find the same slope. If I want perpendicular equations, perpendicular, the symbol for perpendicular is an upside down capital T. Perpendicular equations have negative reciprocal slopes. So if I have a slope of 1/3, a line perpendicular would have a slope of reciprocal, which is 3/1, but make it negative. So if I had a slope of -2/3, a perpendicular line would be flip the 2/3 to 3/2, and since it was originally negative, now it's going to be positive 3/2. So, taking a look at parallel lines, let's take a look at an equation in the form y equals 2x plus 3, and let's say I want a line parallel, symbol for parallel is here, that contains the point -3, 2. So to do that, I'm going to pull the slope off here, and I'm going to use this point. Now that I have a slope and a point, I'm going to use point-slope form. So I'll say y minus, my y value is 2, equals my slope is 2, times x minus, my x value is -3, so minus -3 is a plus 3. Then I would decide what form that I need it into. Let's say I need slope-intercept. I would distribute the 2, so it would be 2x plus 6 equals y minus 2. Then I add 2 to both sides. So y equals 2x plus 8. This line is parallel because the slope is 2, and it originally contained that point -3, 2. Let's take a look at another example. Assume that the equation is in standard form. Let's say 3x plus 2y equals 8. And we want a line that is parallel but contains the point, let's say 1, 4. So first, to find parallel, I have to figure out what the slope of the original line is. To find slope, I'm going to put it in slope-intercept. So I subtract 3x from both sides. That gives me 2y equals -3x plus 8. Then I divide everything through by a 2. So y equals -3/2 x plus 4. The only part that I need is my slope, which is -3/2. I'm going to use my slope now and my new point to plug into an equation. So, y minus 4 equals -3/2 times x minus 1. If I needed to change the form, I could. Otherwise, I'm done. Let's now look at perpendicular. We need the negative reciprocal slope. So let's start from an equation. Maybe y equals 1/2 x plus 4. Here, my slope is 1/2, and let's say we're going to use the point 1, 2. For perpendicular, I'm going to use the slope, but I'm going to flip it upside down, so it's going to be 2/1. It was originally positive, so now it's going to be negative. So I'm going to use a slope of -2/1 and my point. To plug in, I say y minus 2 from my point equals -2 times x minus 1 from my point. Then if I needed to distribute and simplify, there would be -2x plus 2 equals y minus 2. Add 2 to both sides. So y equals -2x plus 4. If I needed to get it to standard form, I would add 2x to both sides. So 2x plus y equals 4. Let's look at one more. One in standard form, 3x minus 4y equals 7. Let's say we need a line that is perpendicular and contains the point, let's say 2, 3. So first, I've got to take my original equation and find the slope. To find the slope, I'm going to get it in y equals mx plus b slope-intercept form. So I'm going to subtract minus 3x from both sides, which gives me negative 4y equals negative 3x plus 7. Divide both sides by negative 4 every single part. So now I have y equals 3/4 x minus 7 over 4. The only part that I need is my slope. Slope is 3/4. To use it in my new equation, it's going to flip and be 4/3. The original was positive, so the new is going to be negative. Now I'm going to use my point and my slope and write my equation. Y minus 3 from my point equals negative 4/3 times x minus 2. If I needed to change the form, I could then change the form.